Lesson 9, Selected Problems from WAEC, Part 1. Example 35. The universal set S is equal to this, and we have the subsets S, Y, and Z. Roman figure 1. Given that the diagram represents the sets above, copy and fill in the elements. You have the diagram, then find Roman figure 2, S intersection Z. Roman figure 3, S intersection Y complement. Solution. The first part is to fill in the elements. You have set Y. It has 3 elements, 2, 3, and 5, and you have them in this form. If you look at set S and Y, the elements in set Y are also in set S. In other words, the intersection of sets S and Y, the elements are 2, 3, and 5. So you have the same elements already. To complete set S, you need to add 1 and 4, and that is what you have here. Here, you can also say that Y is a subset of S. Look at set Z, the elements are 6, 8, 10. That is what you have here. Now, let's come back to the universal set. Considering the subsets S, Y, and Z, we have 2 elements, 7 and 9, that are not in any of the subsets. You write them anywhere in the diagram. Roman figure 2, we are to find S intersection Z. Look at set S and Z. They have nothing in common. So the intersection is an empty set. Roman figure 3, S intersection Y complement. So you need to get Y complements, the elements in the universal set, but not in set Y. Set Y has 2, 3, and 5. So let's come here and remove 2, 3, then let's remove 5. So the remaining elements 1, 4, 6, 7, 8, 9, 10 becomes Y complement. So you get the intersection of Y complement with S. The common elements are 1, then you have 4. That is all. So the intersection of S and Y complement is equal to the set with the elements 1 and 4. Example 36. Given that set P is equal to S such that 1 is less than equal to S less than equal to 6, and set Q is equal to this, S such that 2 is less than S and it is less than 10, where S is an integer. Find the number of elements in P intersection Q. Solution. Set P is equal to this. By the given range, 1 and 6 are inclusive. So you list the elements between 1 and 6. Set Q is equal to this. By the given range, 2 and 10 are not included. So you have to list the elements as from 3 to 9. You have it in this form. Then you get the intersection. The common elements between set P and Q. You have 3, 4, 5, 6. The number of elements in the intersection is equal to 4. You have 4 elements. The correct option is A. Example 37, set A is equal to this, set B is equal to this, and set C is equal to S, such that 3 is less than S, less than 9 are subsets of the universal set U equal to this. Find A. Part of the question: A, intersection, bracket open, B, complement, intersection, C, complement, bracket close. B, bracket open, A union B, bracket close, intersection, bracket open, B union C. Solution: you have the given universal set, you have subset A, subset B, and subset C. The given range of subset C implies that 3 and 9 are not inclusive. You list the elements between 4 and 8 in this form. Now let's get B complement. The elements in the universal set but not in set B, they are the complement. You have it in this form, the same as C complement. A part of the question, we have to get B complement intersection C complement first. So you compare this set to this set. They have known element in common. That means the intersection is an empty set. If you compare this set with set A under intersection, there is no common element because of this result. So you also have an empty set. B part of the question: before this operation, you need this set and this set. So let's get A union B. The combination of all the elements in set A and B without repetition, you have these results. B union C. The combination of all the elements in set B and C without repetition, you have this result. You are to compare this set with this set under intersection, the common elements to both sets, and you have this result. 2 is here, 2 is here, you record it. 3, 3, you record it. 4, 4, you record it. There is 5 here, there is no 5. That means 5 is not common. You have 6, 6, 7, 7, 8, 8, 9, 9, and you have this result. Example 38. The Venn diagram shows the number of students in a class who like reading, dancing, and swimming. How many students like dancing and swimming? Note that there is difference between those that like dancing and swimming and only dancing and swimming. From here is dancing and swimming, while only this place is dancing and swimming only. So let's represent this place with letter S, so that dancing and swimming means the intersection S. Let that set be equal to S plus 2. So you need to get S and add 2 to it. You can use either all the elements in the dancing or swimming subset. So here we have 6, 3, 2, S. We are using the swimming subset. You add everything there, you equate it to 16 in order to get S, and that is what you have here. You have 11 plus S equal to 16. To get S, transfer 11 to the right hand side. S becomes 16 minus 11, that is equal to 5. Therefore, S plus 2 becomes 5 plus 2, and that is 7. The correct option is A. Example 39. In a class of 40 students, 18 passed mathematics, 19 passed accounts, 16 passed economics, 5 passed mathematics and accounts only. Take note of this term. It is very important. 6 mathematics only, 9 accounts only, 2 accounts and economics only. If each student offered at least one of the subjects, A, part of the question, how many students failed in all subjects? B, find the percentage number that failed in at least one of economics and mathematics. C, calculate the probability that a student picked at random failed accounts. Solution: let M represent mathematics, A accounts, and E economics. From the question, the universal set, which is equal to the union of the three subsets, is equal to 40. Those that passed mathematics, they are 18, accounts 19, economics 16. Mathematics and account only, you have 5. Mathematics only 6. Accounts only is 9. Accounts and economics only is 2. Those that pass the 3 subjects, they are unknown. Let us denote that number. Already we have mathematics only, we have mathematics and account only. So let's get mathematics and economics only to be Y. Then economics only to be Z. Because we have this and this, we need the third one. So you draw the diagram with the 3 subsets. This is universal set. So this is the subset for mathematics. The intersection is S of the 3 subjects. Mathematics only is 6. So this place is only mathematics. It is 6. Here is accounts only. That is 9. Economics only is Z. Mathematics and account only is 5. Mathematics and economics only is Y. Accounts and economics only is 2. Is 2. For us to do anything, we need to find S, Y, and Z. The way it is, you need to get S first using the accounting subsets before you can get Y and Z, because in the accounting subset the information is complete. So you add everything and you equate it to 19. We use the account subset to get S. By adding everything in that subset, you equate it to 19. You have this result. And finally, s is equal to 3. To get y, we use the mathematics subset. You add everything in that subset, you equate it to 18. You have it in this form. Previously, s is 3. You replace s with 3 in this form. 5 plus 6 is 11. When you add and collect like terms, y is equal to 4. To get z, we use the economics subset. By adding everything, you equate it to 16. You replace s and y with what they stand for in this form. You have this result, and z is equal to 7. A part of the question, you are asked to find the number of students that failed all subjects. Let that number be f. From the question, students who passed plus students who failed, the sum is equal to 40. So those that passed is addition of everything in the subset. You have 6, 9, z is 7. You add these ones together plus f, those that failed, equal to 40. When you simplify further, you have this result. F becomes 40 minus 36, and f is equal to 4. B part of the question, percentage that failed at least one of economics and mathematics plus those that passed at least one of economics and mathematics is equal to 100%. We are interested in this one. You transfer this one to the right, it becomes minus. So we need the number that passed at least one of economics and mathematics. At least means those that passed economics plus those that passed mathematics plus those that passed the two subjects together. That is 6 plus 7 plus 4, and that is 17. You express this one as a percentage. It becomes 17 over total students, 40 times 100, and that gives 42.5%. For us to get this one now, you subtract this for this from 100%. You have it in this form, and your result becomes 57.5%. C part of the question, probability those that failed account plus probability those that passed account is equal to 1. To get those that failed account, you have to transfer those that passed account to the right hand side. You have it in this form. So let's get those that passed accounts. It is equal to number that passed accounts over total students. That is 19 over 40. You come back here, which is this. It becomes 1 minus those that passed accounts. Their probability is 19 over 40. You have it in this form. You can write this as over 1. The LCM is 40. You have this result, and you have 21 over 40 as the required probability. End of lesson 9. Thanks for following to the end. Don't forget, watch out for more from the voice of Peter Kors. If you are not safe, your life is in crisis, your life is in trouble. To avoid all of that, you have to give your life to the one that can save you, and that is the Lord Jesus Christ, and confess him as your Lord and personal Savior every day of your life. If you are saved already, congratulations. Live righteously, and be prepared, because on the last day some will be taken and some will be left. Be good to yourself, stay out of trouble, study your books, do the needful at all times, flee every appearance of evil, don't defraud others to make money, find something good and genuine to do with your hands and your brain, and the Lord will bless you. Goodbye and stay tuned.